Good day. This morning we shall be discussing how to divide surds, what we call surd rationalization. So we'll be discussing how to multiply surds involving conjugates, or we'll be discussing monomial surds and binomial surds. Later we'll be dealing with how to simplify surdic expressions. Okay, quickly, let's assume you are given root 18 over root 2. You are asked to simplify this. Look at example 1, root 18 over root 2. In division, if you have root a over root b, or root a over b, like this one here, look at the root a over b will give us root a. You can split it to root a over root b. Can you see that? Now, so if you have root 18 over root 2, this is already in the splitted form. You can also be written as root 18 over 2, like this, covering a total root. Now 18 over 2 will give us 9, so that will give us root 9, and square root of 9 will give us 3. Do you understand? Okay, what if you are giving root 9 over 7 this way? You can also split it into root 9 over root 7. Can you see that? Of course, you can find the square root of 9 because 9 is a what? Perfect square. And that will give us 3. But you cannot find the square root of 7 because 7 is not a perfect square, and that will still give us root 7. Alright, so what we need to do here is to rationalize. How do we rationalize? Look at this. In this look at this. If you have root a over b, that will give us root a over b times root b over root b. Why do we do this? This is called surd rationalization. We use the root as the denominator to multiply both the numerator and denominator. So we have root a over b times root b over root b. So it's as if we have done nothing, because we use the same root to divide the same root. Can you see? To give us 1. We are still left with our root a over root b. And if you expand that, root a times root b will give us, multiply the surds by surds, a times b will give us ab, so root ab. But if you have root b times root b, that will give us b. Can you see that? Like I told you last class, that root 2 times root 2 will give us 2, root 10 times root 10 will give us 10. So when you multiply a surd by the same surd, it gives us the number inside. That's inside the square root, that gives us b. Do you understand? Alright, so in this case, you have root 3 and 3 over root 7. That will give us 3 over root 7 times root 7 over root 7. So there should be a root here. It should be root 7 over root 7. So we have 3 times root 7 to give us 3 root 7. Root 7 times root 7 should give us 7. Do you understand? This is not 7, this is root 7. Alright, so, and I said, note that when a fraction has surd as the denominator, the surd is rationalized. Like what we did just now is called surd rationalization. To rationalize the denominator of the rational surd means to rationalize the denominator by removing the square root sign from the denominator. Can you see that later, after rationalization, we have just b here, no more root here. So the meaning of rationalization means that we don't want a surd to be at the denominator. We don't want the square root sign to remain. So a way of removing that square root sign is by what? Rationalizing the denominator to make the irrational number a rational number. To make an irrational number a rational number. Alright, two types of surds will be considered here. The first is the monomial surd, and second is what? The binomial surd, which is what we're going to do later. Okay, for a, as I already explained this, look at this. We have a over root b. Now, when we say monomial surd, it means when we have only one number under the square root, like root b, root 2, root 3. Can you see that? These are monomial surd because we only have one number under the square root. So if you have a over root b, and you're asked to rationalize this, that will give us a over root b times what? Root b over root b. So we have a times root b, that will give us a root b. Can you see? But root b times root b will give us what? B. Whenever you have a and you have a times a number that has root, multiply the a by the one outside the root. There's an imaginary one outside the root. This is like 1 root b. Can you see that? But here you have root b and root b. Multiply surd by surd and whole number by whole number. Root b and root b will give us b. So we are done with that. Therefore, can you see that in our final answer we don't have root again? We only have b. I already explained this one. Now for I, we have 21 over root 6. 21 over root 6. What do we do here? 21 over root 6 times root 6 over root 6. That will give us 21 root 6 over 6. But we won't stop there because 3 can divide 21 and 6. So 3 21 will give us 7. And 3 and 6 2. That will give us 7 root 6 over 2. Do you understand? Now the next one is IV. We have this as 5 root 7 times 2 root 3 over root 45 times root 21. Now that we have times all through, we can cut. Okay, so look at this. 5 root 7 is already in its basic form. 2 root 3 already in its basic form. But root 45 and root 21 are not in their basic form yet. So root 45 can be expressed as 9 times 5. So root 9 times 5, which will give us 3 root 5. Right, this one will give us root 7 times 3. Let's leave it the way it is. Okay, of course, you can have 5 times 2. Multiply numbers by number. 5 times 2 will give us 10. Root 7 times root 3 will give us root 21. And we already have 1 root 21 here, so that cancels out. Can you see that? We are left with 5 times 2, which is 10. Then 3 root 5, which is 3 root 5. So we have 10 over 3 root 5. But we cannot stop here because we have what here? We have a surd as the denominator. Whenever you have a square root number as the denominator, you have to rationalize. We don't want surdic number to be found at the denominator. So what you do is say 10 over 3 root 5 times root 5 over root 5. Can you see that? Use that sort to multiply both the up and down, that is both the what numerator and the denominator. So we have 10 root 5 over root 5 times root 5 will give us 5. 5 times 3 15. Now 5 can go in 10. That will give us 5 here 1, 5 here 2. Therefore we have 2 root 5 over 3, which is our final answer. I bet that's clear. So you have these 3 evaluations to do. For number 2, you need to understand binomial denominator before you can solve that. But you can still solve this. How will we solve this? Find the LCM of root 2 and root 8. That will give us root 8. Catch that. Root 8. Now you're not saying if the LCM of root, here you have 1 as a what denominator. So the LCM of 1, root 2 and root 8 is what? Root 8. Can you see that? So root 2 and root 8 will give us what? Root 4, which is 2. 2 times that. So you just like you do a normal addition and what? Subtraction of fractions. Okay, so let's talk about binomial denominator. Now in this case, we have to understand what they call the surd conjugate. Conjugate of a surd. Now one do we need conjugate when we are actually rationalizing binomial denominator? Okay, when an expression contains 2 terms, e.g. 6 minus root 5, can you see that? Or 3 root 2 plus root 3, or 2 root 3 plus 4, etc. And one or both of them contains surd, it is known as binomial surd. I explained that to you before. Now, to rationalize binomial surd, multiply it by its conjugate. That is, change the sign of the denominator and use the result to multiply both the numerator and denominator. Okay. Now, what do you mean by conjugate of a surd? The conjugate of a surd or of a binomial surd is that same surd with opposite sign in the middle. For instance, look at this. The conjugate of 2 root 3 minus 4 will give us 2 root 3 plus 4. Just change the sign in the middle. Can you see that the sign between the terms is changed or is reversed? Okay. Now, if I ask you what is the conjugate of a plus root b, it should be what? A minus root b. The conjugate of root 2 plus root 5 is root 2 minus root 5. Do you understand? Alright, so let's talk about example 1. We have to simplify this. How do we simplify this? Of course, you can see that at the denominator we have 2 terms, so that's a binomial surd. Okay, how do we simplify? Example 1, solution 1. We have 6 over 2 root 2 minus 1. Very simple. We say, okay, 6 over 2 root 2. Now, this square root should not cover 2 minus 1. It's just for only root 2. Sorry. So we have 6 over 2 root 2 minus 1. Now, times 2 root 2 plus 1 over 2 root 2 plus 1. Can you see that? I change the sign in the middle. Then I use to multiply the word numerator and denominator. So I have multiply. It means we're going to multiply 6 by the whole of this and 2 root 2 minus 1 by the whole of this. So you will notice that after multiplying these two together, the surd part is gone. We have a real number as the denominator. So how do we now expand? 6 into that over this times this. So 6 times 2 root 2 will give us 12 root 2. 6 times 1 will give us 6. Can you see? We expand like that. I think we are opening bracket. Now 2 root 2 times 2 root 2. We say 2 times 2, the real number part, the whole number part, 2 times 2, 4 first. Now root 2 times root 2 will give us 2. So that gives us 4 times 2. Can you see that? Then minus 1 times 2 root 2 will give us what? It give us minus 2 root 2. Can you see that? And minus 1 times 1 will give us what? Minus 1. So when you finish that, you see that we have 2 root 2 minus 2 root 2 cancelling out. So we only have minus 1 times 1, which is minus 1. Then we have 8 minus 1 to give us 7. So when you expand this, when you have 2 root 2 times 2 root 2, you have again, we have 2 times 2, 4. Root 2 times root 2, 2. 4 times 2. Then 2 root 2 times 1 will give us plus 2 root 2. Minus 1 times 2 root 2 will give us minus 2 root 2. So 2 root 2 minus 2 root 2 is 0. Then we are left with minus 1 times 1 to give us minus 1. So the solid part is what? Gone. We are left with real part, which is 8 minus 1, 7. We have 2 root 2 plus 6 over 7. Very simple. Alright, the next one is saying 2 root 5 plus root 3 over 5 root 3 minus 3 root 5. How do you expand? 2 root 5 times 5 root 3. Can you see? That will give us what? 2 times 5, 10. Root 5 times root 3 will give us root 15. 2 root 5 times 3 root 5 will give us 6 into 5. That is 6 times root 25. That gives us 6 into 5. Root 3 times 5 root 3 will give us 5 into 3. That's 5 root 9. Then root 3 times 3 root 5 will give us 3 root 15. Can you see that? Then at the denominator, we have 5 root 3 times 5 root 3 will give us 25 into 3. That's 25 into root 9. 5 root 3 times 3 root 5 will give us 15 root 15. Can you see that? 15 root 15. Then minus 3 root 5 times 5 root 3 again. Minus this, minus 3 root 5 times 5 root 3 give us what? Minus 15 root 3. So 15 root 3 will cancel 15 root 3 because they will give us 0 when you add and subtract them. They give us 0. Then we are left with what? Minus 3 root 5 times plus 3 root 5. That gives us minus 9 into 5. Can you see that? That's or into root 25, which will give us 5 later. That will now give us this numerator and this denominator. So when you are done, look at this. You have 10 root 15 plus 3 root 15. That will give us 13 root 15. Then you have this one give us 6 root 25 to give us 5 times 6, 30, and 5 times 3, 15. So you have everything. So you have 30 plus 15 to give us 45 plus 13 root 15. This one will give us 25 times 3, that's what? 75 minus what? 45, and that will give us 30, and that's our final answer. Alright, so for number 3, before we take our evaluation and general evaluation. So okay, we will take evaluation today. Now root 2 times root 2 plus 1 over root 2 all square. It means root 2 plus 1 over root 2 into root 2 plus 1 over root 2. When you have a square, it means a times a. So the same thing. Now now you expand root 2 times root 2. Can you see that? Root 2, okay. We find the LCM here. Okay, you can also find the LCM here. If you find the LCM in this one, because we are adding, that will give us root 2. We have root 2 over 1. 1 in root 2, root 2 times root 2 will give us 2. Root 2 in root 2 in root 2 will give us 1. 1 times 1, 1. Then the LCM here is also root 2. 1 in root 2 is root 2. Root 2 times root 2 will give us 2. Root 2 in root 2 in root 2 will give us 1. 1 times 1, 1. So you have 3 over root 2 times 3 over root 2. Now 2 times 3 give us 9. Root 2 times root 2 will give us what? 2. So you have 9 over 2, which is 4.5. I believe this class is clear. So you have this evaluation to write to solve in this problem. I hope you enjoyed the class. Have a nice time. Thank you.